which
this
is
sounds good.
also
Yeah.
lighting level. Check the lighting. So you see if you got a meter on it or anything. So I can bring the lighting up in here.
It's fine. What happens is as the light level diminishes, it just cuts the color down and goes for just the black and white. So that's all.
Okay.
So,
I give you a little more light. That way maybe just put a little light. So I can go through here if you want, over to here where we want to start shooting.
That's fine. Whatever. Just give us a tour. Penny hasn't ever been here yet at all. So just talk to her.
Regular tour. Okay. This is the main equipment that we use for broadcast, mixing and production and running shows, as well as recording our shows from satellite and from FM for radio broadcasting. We have what's like a little radio station here. We transmit 1,000 watts at 50,000 volts into space to try to home in extraterrestrial intelligences. And we carry cultural and creative music, everything from jazz to reggae to space music.
So-called space music.
And a little bit of Prince now and then, stuff that's more popular too, a little bit. But primarily it's jazz and it's reggae and it's space music. And these are the machines that we use for doing all the on-air things. This is the monitor that monitors the signal on the stereo amplifier broadcast amp, which is left and right channels. They call it an XY stream, and it allows you to see the phase relationship between the left and right channels to let you know if it's okay. You got both channels and the signal phase is correct. This system here is our main monitor amplifier for the studio itself, 120 watts per channel. This is another power monitor here that monitors the output of that amplifier. This is the main program deck where we run 2-hour programs from this, or record 2-hour programs off a satellite. So we interchange between broadcast and recording with that. And then we've got more equipment that monitors on air what we're putting out. This is the broadcast signal as it's going out right now. That's a receiver that picks it up. It's like a special radio that picks up our transmitter signal. And there are more indicators and meters and voltage controllers here to saturate and adjust the signal purity levels and stuff to the transmitter. Multiplex and DX converters, tone test burst generators, and some other equipment that's related to broadcast use. Then over here I got tape decks and other cassette deck for running short programs. Signal processor, signal test generator here. Another receiver, VLF receiver for checking the system if we have a fault or a problem in it. It also lets us know if we have a problem pretty quick. Has an alarm in it. Then we have ventilation and control systems here for cooling for the building. And then we have a 16-tone digital encode system that encodes up to 16 different variable notes so that we can send out on another transmitter. We have two transmitters here. We have a 150 watt and a 10,000 watt transmitter. The 150 watt transmitter carries this binary sequence of 16 different tones that are repeated over and over again, and then it changes twice a week. And then they repeat a different sequence. So we send out a set of binary tones that are controlled by this machine here, which generates. And each one of these little knobs that change to adjust the frequency of the transmitted signal. These screens up here monitor what we're sending out and what we're receiving. This system here is used for monitoring the electromagnetic disturbances that would be given out by a UFO at close range. What you're seeing now is a test signal that's generated in the lab and fed into one channel of the receive system to verify that it is operating correctly. It's a acidulous figure. It's a term used in electronics for waveforms. But that's what this does. This monitors, this lets me know visually if there's something out there and what the frequencies are. That's what's going out over the air. That is the transmitted signal from the main program board. That's what the music signal actually looks like. And then over here we have more receiving equipment and monitoring screens for the purpose of detecting electromagnetics or disturbances. And they also have more signal meters in them, indicators and readouts and other things to set off alarms and stuff like that so it can verify the electromagnetic effects. Different beam tracing patterns that can use, the color scans, different types of settings that can be used, magnification settings, different settings there also, and different sweep rates. And over here we have some other equipment that we use for, this is the vertical marker beacon transmitter, which the 16-bit binary encoder sends the signal to, and then is transmitted out into space. This is the combination of the 16-bit tone encoder as well as the electronic tone generators in this system that generate comparable simultones. There's electronic controllers and timers in here as well that generate other tones and code on-off sequences. And I've got some video and special effects equipment and video imaging and things that we work with for experimental and for visual, and do a lot of different visual things. And I do a lot of artwork and stuff as well, and some of the things that I do involves video and audio production. So I have some other machines that I use to enhance those creative ideas. And this is some of the stuff, and it can also be used in the UFO work too for analyzing patterns, movement in space, or if you pick up an object on a telescope instrument, optical telescope with a camera, you can see it move on this as a bright spot. It pulls it out more.
Oh, really?
There's a lot of things you can do with this kind of equipment. Now we'll go into the laboratory, the main accelerator lab. This is where we have all of the main high voltage equipment. In here we have systems for programming and starting up the equipment in this lab, as well as injecting this one console here we can use for startup or injecting sentences and paragraphs into the data stream going on in music. It turns it into binary code, which is fed in along with the music, encoded into it. So it can be fed out like a whole sentence or paragraph or multiple sentences, telling a story or telling something about the music or about our work here or whatever. Or just a hello, how you doing out there? And this screen over here monitors the electromagnetic signal that's on actually the flux field is a better way of describing it. This monitors the flux field of the broadcast signal from the main high voltage transformer bank down in the lab below, which we'll soon be taking a tour of and looking a little closer at. Coming around this way, you can see all of these big machines here. These are the high voltage impulse multipliers and high voltage capacitor dividers that are used for broadcasting, shall we say, conditioning the signal for final broadcast into space. This is some of the main high energy equipment involved. A lot of it's custom built. There's very little of this on the market at present. It was designed and built pretty much just for this facility. There's large capacitors down below that hold of high voltage pulses and charges, and then releases them at a timed interval to allow the system to build up a bigger charge and pulse the energy out into space at a higher rate, a higher energy rate, which allows you to, of course, reach further. That's basically the idea on that. And then there's all kinds of control. We have other computers and controls, and a timer system that's very accurate. It's like an atomic clock, very precise. We measure time interval and frequency with it. Another piece of equipment for calibrating all of our different things we have to calibrate and monitor and so on. Then over in this section we have more equipment related to the transmitter, the linear controller, and then we have a linear amplifier, which is a 1,000 watt, 400 and some volt output amplifier, which handles from 40 hertz to 25,000 hertz for transmitter frequency, which is the full audio spectrum and a little beyond. And this is what amplifies the music program. And then it's fed into these gigantic transformers down below in this lower level here, and steps up again to about 25,000 to 30,000 volts. Goes to all these machines and multipliers, resonator, and capacitor discs, and is multiplied again to 50,000 or 60,000 volts, and then broadcast out into space. This device, you can demonstrate it here, puts out a fairly high voltage signal. You'll be able to pull a little bit of a spark here. You'll see a little luck with the music if it sticks around long enough. Get a good angle here. Right now we're probably putting out about maybe 15,000 to 20,000 volts. Peak to 60, which is like a 3.5 to 4 inch spark of electricity. And this is all at the music frequency.
Very powerful music.
Yeah, quite. And in a nighttime condition, it's easier to see than it is now, but you can, this tube will glow from the high voltage on these accelerator columns and stuff. The tube glows, your hands feel like they're going to sleep. There's a tremendous electrical charge present here, and will light the tube right up. I may even be able to get a better, I might try traveling to the railing here. Maybe it's a little better. Oh yeah. Looks like it's going to gives you a little bit of an idea of the kind of energy it does have. It's capable of a great deal more, too. Right now, power levels are running at about 25 to 30% on the gauges. You can see on these meters, this is another meter used for monitoring the power demand of the system, or that is pulled from the main power circuits and stuff, or the voltage regulators. And right now, we're running maybe quarter to a third of the full capacity of the system. When it's cranked up, we can throw quite a bit more of the spark and also demand a lot more power, up to about 60 amps of power will run into to go through this system to transmit. So it takes quite a bit of electricity. And then we have all these voltage power control panels, switching systems, and alarm regulators and everything to control and to warn if something goes haywire with our equipment, if we have a difficulty or a fault or that kind of thing. And then we've been working on a system that we haven't even finished, but this whole row of instruments is a 96-channel transmit and 96-channel receive system capable of giving us computer addressable frequencies going out into space, and then the same as receive, we can scan and listen to adjacent frequencies for anything that might be out there that might reply. This was the idea behind this system. Again, this system is still under installation and maybe a year or two away from completion due to budgetary realities. And this is some more of the equipment that's online that is operating, as our monitor screens and our receive and alarm circuits, our detectors. These systems here, we have a machine that's got 1-inch wide tape with 14 channels on it, 14 different individual frequency channels that record information at 30 inches per second up to 100 kilohertz. So it goes to 100,000 cycles per second, which is well above the audible range, and records that, logs it on tape in analog form. And that's a high density analog recorder, high speed, and a lot of channels, 14 channels to work with. So we've got up to 14 separate recorders on there. And then again, this is the same phase monitor signal you noticed on the other screens out in the other room earlier. This screen here is related to the direct input signal, the receive side of the system. This is all right on the receiving end. So this verifies that our receive is working. We've got a little bit of signal loss here, but not much. Maybe 3% or 4% on the very end of that waveform. That's how we know. There's little things that tell you like that. You know how to read these instruments.
Wow.
They can tell you all that stuff. So that's basically what that is. It's a 23-inch oscilloscope, custom built and designed to build the scope circuits and make these work. It's one of the things that most of my life spent fiddling around with and developing. And then we've got even more to see down below. We'll go through the lower level of the lab, and you can see much more of this up close and get wide-angle shots of the lab and how big it really is.
Let's do that.
So we'll shoot some down there. Yeah, here's the tape library. This is all of our
That's
programs.
right. It takes a while for this to autofocus, so I got to kind of be ginger with it.
Okay.
Yeah, I want to be able to get some here. Doesn't want to do it. Switch to manual.
Yeah, maybe do a manual shot on it.
There we go. Okay.
Most of the records. Everything from early rock and roll on up through the early jazz and modern jazz era, and then a lot of stuff like different programs and stuff that came out as promos only, promotional elements of musicians. They only did some promotional things, so that's a lot of what you've got here. You got a whole bunch of parts catalogs where we order parts. These are electrical engineering and catalogs. They're used for engineers and people that build machines and factories that order parts. That's a lot of what we do here. We get a lot of our parts that way. Some we just scrounge around and get, and we have to look a lot. We have to do a lot of looking, a lot of piecing together. But in all of that, we managed to put all of this together. So I guess it's not all too bad for an individual effort. We'll go through this way, and we can see the lab below, the high voltage transformer.
Last question.
dry enough for what we do. This is down below in the lower level of the lab. This gives you a kind of a perspective on how large some of the equipment actually is. This one particular piece of equipment is 18 feet 6 inches high from floor to ceiling, and probably weighs close to 2,400 pounds. This is really heavy equipment and large. It was necessary to build this entire room in a modular format with no floors in the center, just a floor in the basement and a ceiling at the top. You can then shield it and insulate it. And that made it possible to put in modular flooring so we could raise and lower or adjust the floors. And you can take the floors out and have needed sections. That's the main high voltage area here. This is where the large transformers are. There's a 25 kVA and a 50 kVA transformer respectively. It puts out the energy, steps up the music, the broadcast. The signal from the 1,000 watt linear is then leads. Steps up and out in space. Hopefully 1.5 million miles an hour better.
That's crazy.
There's even more equipment in this section. There's equipment everywhere around here, and a lot of wire. It's kind of a wiry place. There's voltage regulators and power distribution equipment that we use for distributing the power through the whole complex and controlling it, regulating it, filtering it, checking it, making sure it isn't too high or too low. And there's also voltage dividers in there that split up the power more evenly so that the power can be fed to the areas where it's needed most and still kept in balance.
Is the quality of the power a real concern here?
And actually, it's quite excellent. Power,
is it?
Yeah, other than during lightning storms and things like that, that's where the conditioners and some of the regulators come in handy to help stabilize those variations, because you do get a lot of lightning effects and stuff. So you do have to stabilize it a little bit and filter it, removing the transients or lightning effects from the electricity. And then we've got wire, many thousands of feet of wire, hookup wire, kind of all over the place, and piles of stuff.
Gramps said that you were just having a garage sale recently, or yard sale?
Mm-hmm.
That was largely to get rid of some of the materials you don't need anymore?
Right, right. There's quite a bit of older test equipment and wire and cable and connectors and holy cow, all kinds of strange, bizarre odds and ends. Just stuff that's very bizarre. Hard to sell though around here. Hardly anyone knows what to do with it or why they would want to buy it. It's kind of amusing because there isn't a whole lot of interest in that sort of thing. It's kind of unique.
Well, I think you've sort of cornered a lot of the market anyway, of electronics.
Yeah, for one person doing it on his own, I guess I have, considering, there's a lot of it out there.
Well, I think everyone figures they'll just leave it up to you, John.
Yeah.
No more than the sum combined total of knowledge on electronics around here. So this is 18 and a half, these poles, or these towers?
The big one over there, the big square one, that's 18 and a half feet high there. These others are about 14 to 16 feet high here. A little shorter.
You have people who help you actually get the structure up.
Yeah, I had a friend that helped me put some of the frames together and stuff, but the rest of that, just once I got it up there in place, I could just build it as I went along day after day and assemble it. These are actually assembled from the top down. Yeah, these are. That's built from the bottom up. Some of them you have to build from the bottom up, some you have to build from the top down. Then they just to build up the extra energy needed to pulse it out into space. You can hear the rattling of the screen in there right now with music going through it. That's where a lot of that sound comes from. If I turn off this auxiliary blower, I might be able to hear a little more of the sounds. There's actually music. You can hear music in this steel framework. You put your ear up in the steel framework. Music coming through that. Yeah, I don't know if you can hear it or not. Watch your arm. You're really close to that high voltage.
Ooh.
The electric feed is really bad. Severely.
That is too wild.
Electricity right now, but so I'm used to monitoring the output signal and the clarity of it. And now the oscilloscope seems to have lost some degree of clarity itself.
So this tells you more than the other oscilloscopes does about about the
somewhat,
signal?
somewhat, yeah. It tells me other elements in the signal I need to know about, like the degree and percentage of modulation, and direct output levels and frequency response of the system on the actual output at this point in the system, which is like the final output stage. Right now we're getting a little bit of distortion not in the output signal, but in the oscilloscope. You need a new oscilloscope, I guess, to get this one repaired. It just went out on me yesterday, by the way. We were using it yesterday and it failed, but this is one of the ways that we can verify and check the quality of what we're putting out. And this is the antenna. This device here is what is a special capacitance type antenna that picks up the energy field from this high voltage machine, collects the electrical field or electrical energy and sends it through a cable to this, to the oscilloscope.
Right.
To take the readings. So it's like a giant electrical probe sensor. And we have stocks of parts and test equipment. There's even more. There's an impulse, high voltage impulse thumper. We like to call it a thumper. It's got timers and impulse magnetics in it. You can feed an impulse signal into the system and pulse it and analyze its efficiency, its curve, to tell whether or not the components in the system are aging or changing. It allows you to test them right with a high energy pulse. You can actually verify if something's varying in there that shouldn't be. And that way, by the waveform you get up back on your oscilloscope, you can tell what it might even be, if you're familiar enough with Gizmo. So over the years we've managed to assemble and purchase a lot of really strange equipment.
So you got machines that look after your machines.
Right. Oh, you have to have. Yes, you have to have machines that can keep an eye on the other machines.
Wow.
What's really distressing is when your whole operation goes up in a giant mushroom cloud and your neighbors look over and wonder what's going on, and they're all they drop their coffee on the table and they run out the door and they oh shoot, it looks like he'd made a boo-boo.
You don't have any small boo-boos, I imagine, around here, do you?
Only minor.
The amount of
very minor
power you're dealing with.
Yeah, there's chances of having a severe one or very small. A lot of safety equipment in this place.
Yeah.
A lot of safety equipment and backup equipment that protects even that equipment. There's two levels of safety in here, and threshold equipment we call the first system is the threshold sensor. If something gets too hot or overheats or fails or goes out, there's an alarm sounds or it shuts it down or one of those other things occurs. One of the things I might be able to demonstrate today is I'm trying to going to do a little demonstration. Yeah. Find that insulated, highly insulated stuff of the make sure everything right. Might do it. The enzymes, no, they're gone and they can't use it. So, fire it. Yeah, so it'll work. I just need a sharp fuse, something you can kind of arc a little electricity with. About the time now I'll try to go up and start the tape again. Those are 30-minute programs on the side. So
okay.
Unless we're running reel-to-reel for the names, which I think we just ran out of signal. Probably don't even have tape hits here by the look of it. Yeah, so I'll have to go up and change the tape. I got to go do a station ID.
You can actually hear the sound
That's bizarre.
in these metal structures. Truss, which was overhead.
On this thing. It's really kind of amazing.
What are we turning up further there?
Security lock on the door. The triggers for the impulses.
Wow.
It'll even cause the video game to lock up on.
Really?
Yeah. Oh, there's a good impulse. I felt that one.
Oh.
It's even higher voltage up above on the other equipment right now. Again.